Hello everyone. Today we're going to be looking at scale diagrams. These come up fairly frequently in construction blueprints and biology, but are also valuable in a few other contexts. A scale factor is used for diagrams of objects. The scale diagram has the same proportions as the actual object. Here we have a few examples of scale diagrams. So first we're going to look at determining a scale factor given a diagram. And here we have a scale drawing of the NASA Space Shuttle Endeavour. The first thing we need to do is find the length of the drawing to the nearest tenth of a centimeter. So measuring from the nose to the tail, it looks like I have a length here of 14.5 centimeters. Now you will likely measure this to be something different than I've done here, depending on the size of the screen you're watching this on, or how your printer scaled this page if you managed to print it. I would encourage you to use your own measured values throughout this video and adapt your numbers accordingly. This should be fairly easy for you to do considering what we've been through this year, but you should take care not to scratch your screen if you decide to place a ruler against it. So I measured the length of the drawing to the nearest tenth of a centimeter to be 14.5. Now the scale used to make the drawing is stated as drawing to actual. We determine the drawing length to be 14.5 centimeters. And off the diagram you can see its actual length is 37.2 meters. Scales are sometimes communicated without units, so something like maybe 1 to 25 might be fairly common. But if the units of the drawing are different than the units of the actual object, we should include the units with the scale. And we should generally try to reduce this ratio if we can. Probably the quickest way we could do this is to divide 14.5 by 37.2 in your calculator, and attempt to see if you can produce a reduced fraction out of that. In this situation, this is an irreducible ratio, so we'll just leave the scale like that. Next, the scale factor is the number that is created from the ratio of two corresponding measurements using the same units for both measurements. Units are never stated with the scale factor. So the scale factor is often reported as model divided by original, or with this example, we could call it drawing divided by actual. In order to determine the scale factor, we need to make sure that the drawing units and the actual units are the same. So in this example, it would be helpful to know that 1 meter is equal to 100 centimeters. We could either choose to convert the drawing length into meters or the actual length into centimeters. I think I might choose to convert the actual object into centimeters rather than converting the drawing into meters and getting a very small number. So I can keep the drawing units as 14.5 centimeters, and in order to convert 37.2 meters into something in centimeters, I just need to multiply it by 100. So 37.2 meters times 100 centimeters per 1 meter, and we get 3,702 centimeters for the length of the space shuttle. So in order to determine the scale factor, we do 14.5 centimeters divided by 3,702 centimeters, and we get a number of 0.0039168017. And that would be a unitless number because centimeters cancels with centimeters. If you want to adapt that number to your own measurement, you'll just change 14.5 into whatever number you measured for centimeters and divide that number by 3,702. For question number 4, often with scale drawings there is a bar that's included that shows the relative size of the drawing to the actual size. We need to determine how large the actual bug is if the bar in this diagram is 2 millimeters long. According to my measurement here, it looks like the bar in the drawing is 1 centimeter long. In order to determine the scale factor for this drawing, we do scale factor equals model over original, and the model bar length is 1 centimeter. The actual bar length is 2 millimeters. Knowing that 1 centimeter is equal to 10 millimeters, 2 millimeters is equivalent to 0.2 centimeters. We just divide this number by 10. So we can put 0.2 centimeters in for the actual length of the bar, and if we do 1 divided by 0.2, we get 5. So centimeters cancel, and we get a scale factor of 5. Now we need to figure out how large the actual bug is. So according to the measurement of the drawing, it looks to be about 9.3 centimeters long. So if that's the length of the bug in the drawing, 9.3 centimeters, we need to divide that number by 5, and we get an actual bug length of 1.86 centimeters. Or if we want to express our answer in terms of millimeters, we just need to multiply this by 10, because each one of these centimeters counts for 10 millimeters. So that would be equivalent to 18.6 millimeters. So when you're doing these questions, keep in mind the scale factor gives you a way to translate from the original to the model, because the scale factor is determined by going model divided by original. In question number 5, the CBC wants to put its logo on a new billboard outside its offices on Memorial Drive. If the logo looks exactly like the one shown, but is to be 5 meter by 5 meter on the billboard, what scale factor is to be used? So according to my measurement on the page, it looks like the logo is 5 centimeters wide by 5 centimeters long. So again, scale factor is given by model divided by original. And if we call this the original, then the model would be on the billboard. So the measurement required on the billboard is 5 meters, and the dimensions we determined from our page here were 5 centimeters. Keeping in mind the scale factor has to be unitless, we need to convert each of these into a consistent measurement. So it'll be helpful in this situation to know that 1 meter is equivalent to 100 centimeters. So if each one of these meters represents 100 centimeters, the dimensions on the billboard should be 500 centimeters. And if we divide 500 by 5, we get 100. So that means we'd need to scale this drawing up by a factor of 100 in order to fit it on the billboard. For question number 6, the concert promoters for the now postponed Matchbox 20 concert tour want to put the logos below on t-shirts. What would be a reasonable scale factor for the logo? Depending on the size of t-shirt, this might end up being something like 8 centimeters wide as measured on an actual t-shirt. And if we measure the width of this logo as it is on the screen or on your page, it looks to be about 8.2 centimeters wide. So as it is on the screen for me, it might be fine to use a scale factor of 1 and have the width of this on the t-shirt be 8.2 centimeters. But if we demanded the width of the logo on the t-shirt to be 8 centimeters wide, we would determine the scale factor by going model divided by original. And if we call this the original and the version on the t-shirt the model, then we would go 8 centimeters divided by 8.2 centimeters, and we end up with a scale factor of 0.98. In question number 7, we have a structure that's actually 5.5 by 8 meters, and we need to use a scale factor of 1 over 100 to make a scale drawing of the base. So what needs to happen here is we need to divide each of these dimensions by 100. So 5.5 divided by 100 gives us 0.055 meters, which is a length that's a little impractical to measure, but if we know that 1 meter is equal to 100 centimeters, we can divide this number by 100, moving this decimal over to the right twice, and we would have 5.5 centimeters. And similarly with 8 meters, if we divide that by 100, we get a new length of 0.08 meters. And if we want to transfer that into a more ruler-friendly measurement, we get 8 centimeters. If you have 2 rulers set up like I do, you can draw this fairly quickly. So we have 8 centimeters on one dimension and 5.5 on the other. So it would look roughly like that. So in general, if the scale factor is between 0 and 1, then the scale diagram is a reduction of the actual object. And if the scale factor is greater than 1, then the scale diagram is an enlargement of the actual object. So that's it for me for today. You can try this question on your own, and I'll see you next time.